Example number 1. Example of linear and nonlinear equations. Example of linear equation is 3x plus 2y equal to 7, 1 half x plus y minus pi z equals square root of 2, sine pi x1 minus 4 x2 equal e squared. So you notice that the variable in the linear equation x, y, and z, the exponent is 1. Okay, and the example of nonlinear equation is x1, y, x to the 1, y to the 1 plus z equal to 2. So even though the x exponent of the x is 1 and y also exponent is 1, but because x and y multiply, so the exponent we will add when you multiply the x and the y, it makes the degree is 2 in this case, so that's why it's not linear. The variable x should not be in the exponent, should not be in the exponent's form in this case, and the variable x cannot be in the argument of the trigonometry function. Solutions and solution set. Solution of a linear equation in n variables is a sequence of n real numbers s1, s2, s3, Sn that satisfy the equation. Satisfy the equation means when you plug the number into the equation, you get the true statement. Okay, and the solution, all solutions, the set of all solutions of a linear equation is called solution set. That means after you find out those solutions and you make the set, so it's called a solution set. Let's look at example 2 and example number 3 below so that we can understand the solution and the solution sets more. So in example number 2, we got x1 plus 2x2 equal to 4. I solve for x1 and I got 4 minus 2x2. So after that, I will use a parameter t. Okay, so I will let x2 right here. Okay, so I will let x2 to be t, and t is my real number, so any real number. And then I plug into the x1, so I will get 4 minus 2t. So x2 will be a any free number, but x1 is not free. x1 depends on x2. Okay, so we got, this is called the solution set. This is solution set. And to get the particular set, particular solution, we just let t to be any number. Okay, so for example, I let t to be equal to 1, then my x2 should be 1, and x1 should be 4 minus 2 times 1, then you got 2. So this is just one solution. Or you can let t to be different number. Okay, so let's say 5, then x2 is 5 and x1 is 4 minus 2 times 5, so 4 minus 10, and that's give negative 6. So this is another solution. Now example number 3, I will just pick one variable to solve. So let's say I pick x, so I will get 3 minus 2y plus z. And for the last equation, to get the last equation, I will divide both sides by 3. So I will get 2 over 3y here plus 1/3 z. So 1 minus 2 over 3y plus 1/3 z. And for this last equation, I will have 3 numbers for y and z. Y and z will be free. Okay, so I will use t for y, and then I will use z, the s for z. I cannot use t again. Okay, so that means I use differently for y and z. It can be the same number or they should be different. And then to find the x value, I plug in 2 over 3 t right here for y plus 1/3 s. Okay, so this is the solution set, And to get the particular solution, you can let y equal to 0 to be easier. We can make z equal to 0 also, okay? So t and s are 0. Of course, we can make different, anything you want. And then you plug in the x, so you get 1 for the x. So this is just one of the solution for example number 3.